Hello, everyone. Hello, and welcome to this webinar. Hi, this is a webinar from OPIT, Open Institute of Technology, and we're going to talk about something very interesting of cloud computing with Professor Lokesh. My name is Greta. I'm head of marketing and admissions at OPIT, and today I'm here with Lokesh Vij, our professor. Hi, Lokesh. I'm going to give you a very brief introduction about OPIT. Then I leave the floor to Lokesh for this presentation about cloud. The title is From Netflix to NASA, the real world examples of cloud computing. And then after that, I'm going to just go briefly through the programs and we can answer questions about Lokesh presentation and anything you want to know about OPIT. So, few things first about us. I will start from our mission to us is very dear, the idea to unlock progress in employment on a global scale by providing top quality tier one and affordable education in the specific field of technology. So technology is the field where OPIT specializes with university degrees. And I'll tell you a little bit more about that now. So first of all, what set us apart? We are an institution that is accredited at the European level. We're part of the system which is called EQF, and we are accredited by MFHEA in Malta. Our programs are also recognized in the US and Canada through WES. Our programs are fully online. They're very flexible. And as I said, focus on technology. So we're talking about computer science, cloud computing, artificial intelligence, data science, digital business, cybersecurity, everything that is around technology. They are career aligned. So they've been designed with the thought of companies in partnership with them as well, because we truly believe that this is something that can actually support and help people in doing better in their career. So this is our main focus. And we believe to be affordable and just flexible enough for you. And what's the most important, the support is always there available for you. And we talk about a little bit better after the presentation of Lokesh. Um, just one thing about the quality and about also why we focus on technology. Our professors come from different type of backgrounds, but most of all, the most important thing is all of them have a practical experience either in companies or from other like projects and universities. So it's very important for us to bring to class their expertise. So we have professors from Amazon, from NASA, from very big banks, from Microsoft. Our rector has been also Minister of Education in Italy, and he brings his expertise, is like the way of thinking, the way of seeing how these programs must be modern, they must be related to what companies need today, and they have to be very practical. And Lokesh today is one example, of course. So now, without any further ado, I will leave the floor to him to talk about from Netflix to NASA. So the real examples of cloud computing. And please, if you have any questions, you can just write in the chat and the Q&A, and we will be happy to answer them in real time after Lokesh's presentation. So I'll just leave it to you now. Thanks.
Sure. Thank you, Greta. I hope I'm audible and you can see my screen as well.
Perfect.
Thank you. So welcome everyone. Thank you for this today's session and taking out time to understand the cloud. So how I'm going to present today is I will briefly introduce what the cloud is. And because we need to understand what cloud computing is, then we will talk about some real life case studies. I'll take up 6 to 7 case studies. And those case studies tend to be pretty extensive when we pick up any case study. So what I've done is like I will try to narrate as much stories as I can and try to relate what technology stack they use, which cloud provider they use, and why they do it. Like if for us to understand cloud, the most promising and the most pressing factor is why those companies out there, why they chose a particular cloud provider, or why they wanted to migrate to cloud. Then towards the end of it, we'll talk about different career options in cloud, and then how you can actually get started. Again, I will answer all the question and answers, whatever you have towards the end of it. So let's start with what exactly is cloud computing. But before it, like, are you even aware that you use cloud every day? So for sure, some of you might be aware of it, but eventually, if you see, whatever tech stack we use, whatever applications we use now, which are around us, they actually are based on cloud. To give you some of the example, this webinar is being delivered through Zoom. So Zoom is actually a cloud-based app. So then YouTube, that is another example of a cloud-based app. Your WhatsApp, your Instagram, your Dropbox, and Spotify, all of them. Like it's not only this. Just these are some of the examples to name you, but most of the apps, I mean, you touch it on your phone, your apps, on your mobile, or on your desktop. Most of them, they use some kind of cloud computing here or there. So let's try to go and understand, what of all definition of cloud computing. So when we talk about cloud, the question, we always think about cloud differently. We talk about servers, data centers, we talk about a lot of other things, but there is a specific context to it. And it is very important for us to understand, first of all, before even talking about case studies, what exactly cloud computing is. So the cloud computing, let's take some examples. So for example, the first thing which we could all relate to is, cloud computing is just like electricity. So nowadays we know that, electricity comes to our house, they power so many devices. But what is important for us to understand is that how this electricity is delivered to us, how we actually consume it. And so, so how much electricity we consume is all metered. So that means we only pay for the electricity we consume. And this is the same kind of model which actually is available in cloud computing. And if I go, let's say 100 years back, or let's say not even 100, let's say 80 to 90 years back, for example, then what we used to have is it's a era where we did not have any grids, what we call it power grids. And during those days, for example, factories, or even the rich people in their houses, they used to have generators. So there were no power lines back then. It's only the generators which would power factories and houses. So all the concept of delivering electricity to homes as a service started off when we created grid, the electricity grids. So that's how it started as a service. Similarly, you can think of an example of your telecoms. How telecoms they deliver, or how we can talk using the telecom giants. That is a kind of service. So this is a kind of a shift which is actually happening. So another example which I can give you, which you can relate more to, is initially, let's say 20-25 years back, we used to have Microsoft suite, Office suite. So even if, let's say, I just want to use Outlook, or let's say if I just want to use Microsoft Word, we have to install everything, we have to pay for everything. Then the model changed, with Outlook 365. So it's now an online service. So that is how things have changed. So it is more of how these are things, the things look as if you are consuming as a service. Another example which you could relate to is how the cloud computing mindset has changed is, how do you own a apartment, or you rent an apartment, or how house per se, right? When we, let's say, if I'm owning an apartment, or I'm owning a house, then I'm responsible to do everything. Similarly, in the good old days, when people have not yet migrated to cloud, all the data centers, all the computing power, it's totally up to me. I have to pay for it. I have to set up engineers to take care of all my servers. But when it comes to renting the apartment, some of the things can be actually offloaded. So I might have to pay for them, which includes within my rent agreement or lease. But eventually what I'm trying to do is I'm just pushing back some of the things for someone else to manage. So that is what exactly cloud computing is. Let's look at one of the definitions. So this is NIST is a standards body. So how they define cloud computing is, so there are a lot of very particular keywords which have been used here. For example, they say that it's a model which enables ubiquitous, which is everywhere. It's a convenient, why it is convenient is because anybody can use it, and given any device, and how actually is being delivered. It is delivering using an on-demand network access. That means internet. So anything, any cloud computing power which we consume is delivered to us via internet. And how they deliver, where it is coming from, it's coming from the shared pool of resources. And these resources are your networks, your machines, your servers, your storage, and whatnot. How they are delivered from to us is from your data centers, which all the cloud providers are going to manage. Now, again, important thing is, these can be rapidly provisioned. What is meant by rapidly provision is on a click of a button, you can simply create a machine, and that machine, for I'm talking about a virtual machine, it can be created within a span of few seconds. And when you don't need it, you can simply turn it off. And that's what is meant by, rapid provisioning. Similarly, we are talking about a minimal management. That's why I said, within seconds, you can quickly turn it up, do the task, and turn it off. So, and how are you going to pay? You're going to pay only for the service which you have consumed, only for the time which you have consumed that service. All right. So, and there's one more thing which we need to understand before I move on is some of the essential characteristics of cloud computing. First of all, it is on demand. As I said, so we are going to consume a cloud computing service for only a particular time. So that is why, you will find on internet that they say it as a pay as you go model. So similar to electricity, the how much electricity we consume, it's on demand. If we need it, we'll consume it by turning on the switch, and whenever we are done with our task, we can turn it off. Similarly, we have a broad network access. As I said, all these services are delivered to us via internet. So it can be using your, mobile computing. It can be used on a desktop, but all the services, they actually are delivered to us using internet. Then it has a shared pool of resources. So whenever we talk about a definition, what you need to understand is, the pricing advantage is hidden here within the shared pool of resources. Because if multiple people, or within this characteristics, what they're trying to say is, if you might have heard about multi-tenancy, that means, one server is being shared by multiple different clients, multiple different tenants. That is where you tend to share all those resources, and that's where the power of, your pricing is built in. Why you have to pay less when you are consuming the same service, when you're consuming the same computing power on your on premise, because now the things are shared. The next thing is your rapid elasticity. You can quickly scale up. Let's say, using two servers, you found out that let's say you created an app, and that app became so popular. For example, Pokemon Go, it became so popular within few days. They have to have a model which can be rapidly elastic, which can expand, which can increase, so that they can take more user base. So that is what is meant by elasticity. And elasticity doesn't mean only expanding. It is just that, based on demand. If the demand is low, it can actually go back also. We can turn off the servers which we don't use. And in the end, it is a metered service. So the service is metered, it is measured. That means the quantity or the amount of time which we use those services for, we only pay for those services. Okay, so these are the kind of characteristics. Let's start with our case studies now. So I will talk about some of the examples. And what I will specifically talk about is I will specifically talk about the stories, those background of those companies, why they were actually forced to actually move to cloud. So that will be how I would try to describe those. And usually this kind of case studies which I'm presenting, I usually present them in a 90 minutes long lecture. And then we try to, solve, what are the problems, what are the pain areas, and how they were solved. So some of the terms which you will see on the case study, again, I will not go deep dive into a technical bit, but if you have any question, you can specifically ask me. I can tell you how they can were or they can be implemented. Let's start with Netflix. So Netflix, as you all know that, it's a streaming platform. So what happened, if I talk about 2008 or before 2008, so Netflix, I'm not sure how many of you would know that it was just a kind of a DVD, on a rent kind of an environment, wherein you can go to Netflix and, you can rent a DVD, and you can, once you are consumed, you watch the movie, or you can return it. So what happened during that area, the stage was there were two specific events which happened in 2008. The first specific event was in 2008. The company thought of using the same environment to put an online streaming platform. Back those days, 2008, online streaming was not that popular, and even the problems with buffering and all those things were really there. So that is the first thing which they thought about in 2008, that whether let's start with streaming. That's what Netflix thought. And another thing was which they were bitten by. In 2008, one of the databases actually got corrupt, and because of this DVD business, they were bitten by it, and they were having a design which was not that resilient. It took them 3 days to bring back their services. So that was the prime moving factor of them thinking, what they should do if they want to expand their business. And also, if you're talking about streaming, if the streaming services goes out for 3 days, it's a big issue with the customers, and it is a reputation of the company which can be brought down. So that was the prime, main thing. So they started off building their own servers, but eventually, they started getting more popularity, and they wanted to expand. Now their servers were like mostly constrained. If you see, like, I've tried to draw a picture here. So the problems there were with Netflix was that when their streaming services went online, there were millions of concurrent users. So now, for example, let's say a movie which is very popular. So you can think of many concurrent users. Many concurrent users here means multiple users going to watch the same movie. So how can they deal with this situation? So they saw that their current on-premise servers, whatever the servers they have procured, they are not able to catch up with the demand. And it was the CEO of the Netflix then said that they are lacking behind. What they are always in the catch-up mode. They never ever were able to provision a capacity which will serve all the customers. And apart from that, they have to have a massive content libraries. If you are serving just a minute content, very small content, that is not attracted to the customers. Apart from that, if you see now, the Netflix, it is going to give you personalized recommendation. How would you do that? Not only streaming, but they just wanted to add other things to their, capabilities. How would they do? So that is what exactly happened or started happening in 2008, and that is what pushed them. So that is what pushed them to use a cloud service provider. So they went ahead with AWS, and what they started using their bunch of bunch of services which I mentioned here. So I can explain if you have specific questions. So for example, they started off with virtual servers. They wanted to have a storage for their movies, or what kind of data they store, even your personal data also. They used to store your personal data on NoSQL databases. And for personalized recommendation, so they use some kind of data warehousing capability. They have actually ran a context aware machine learning algorithms to actually give you recommendations. So recommendation, you can see if you go to your Amazon, even in Netflix, if you're aware, if you watch a movie, so then the same movie actually, so if somebody else watches, and if your taste actually matches, it is going to recommend you another movie which you might also like. Apart from that, what is important is they club themselves with the proprietary CDN, which is a content, it's a content distribution network. So what it does is, the content is delivered close to where you are. So this is a concept of edge computing. Apart from that, what they actually done is they have done, microservices architecture. So if you think about Netflix, so Netflix, think about, for example, if you are logging into Netflix, that is one service. So they have broken down the entire functionality of Netflix into different services. That is what is called microservices. Streaming can be thought about a different service. Payment can be thought about different service. So multiple different service, they are breaking it down. And this is what actually exists in cloud these days. So you might have heard about containers. You might have heard about Kubernetes, your Docker. So they all fall under the microservices architecture. This is background what they have actually used. Eventually, what were the success factors? So they wanted to address some problems. They actually really addressed those using moving to cloud. So they got scalability and elasticity. Scalability means, again, like based on the demand. If the demand is more, they were able to scale up. They were able to have all those different virtual machines. Then if the demand goes down, they were able to turn it off. They were able to survive. They had high availability. So that is one of those the prime factors. When they had a database corruption, we took them 3 days to restore. So the high availability, and that ensured near zero downtime, because your cloud is global. So you can have multiple data centers at multiple locations with your backups and everything up there. And then they were able to spend more time on rapid innovation, and further enhance their features by bringing in more things. Apart from that, in the end, I've mentioned about cost optimization. Though for Netflix, cost was not the driving factor. It was the things which they actually wanted to do, which they were not able to do with the current data center. But eventually, when they moved to cloud, they realized that they were able to optimize cost. They were able to save so much of cost, and they passed on some of the benefits to the consumers. So this is what Netflix was all about. Let's talk about the next one. Very popular platform, which is Spotify. So same thing happened with Spotify. Spotify was, if I say in Europe, it was pretty advanced. But now you would think, if Spotify was that advanced, why would that move to cloud? Why would they think of moving to cloud? So eventually, if you think Spotify in back those days, so they were one of the pioneers. If I talk about in many different fields. I'm not sure how many of you have seen the Netflix documentary on Spotify, the playlist. So though they were actually pioneers in many fields. So they were pioneers in the microservices architecture as well. So what exactly happened with them was, back then, they have their 4 data centers, which were geographically disparate, in the European region. And these guys, the Spotify guys, was the first one in the Europe to have a largest Hadoop cluster. So this is the kind of the technology which they were dealing with. Now, what was the problem, which they started facing? So they also ran into the same issue that they were streaming the music application this time, and their user base expanded like anything. It was hundreds and millions of users, which were registering themselves globally. So eventually, they were also in the same situation, just like Netflix. They were just trying to catch up, but their demand was more and more and more. And also, in this case, they just wanted to scale dynamically. Now the problem with, so how would you do that? There are different customers, or there are different different listeners who registered on Spotify. They were throughout the world. But how would you set a context? How would you ensure that you set a context for them to recommend them? So this is what you like, and this is what you might also like. So that is how it is. Apart from that, so the problem which they faced was again that uh, the streaming and the audio streaming service, which was delivered to millions of users, they had issues with buffering. And also, when multiple users are listening to the same soundtrack, how are you going to ensure that you are going to deliver a service which their motto was to deliver them as soon as you click the button, the sound or the audio should start playing, the music or the song should start playing. So that is what their eventually journey was. So it in 2016, you might be surprised, like in 2016 they started off their journey to cloud. So they selected a Google Cloud Platform, and they did a bunch of things. As I said, they were pioneers in microservices. So that is where they thought of going with Google and the Kubernetes engine. Just to give you a bit of background, so if you think Kubernetes is the container orchestration service, so Google actually, before offering their Google Cloud Platform to the outside world, Google actually had their own cloud platform, and it was all Kubernetes. It is their platform. Eventually, Google came up with Kubernetes, and then they shared this to the whole world. They made it open. Eventually, that is a bit of a background. So eventually, Netflix thought that Google, just like them, they were pioneers and they were way ahead in the technology. They said, let's partner with Google. They could have went to AWS or Azure, any cloud platform, but they thought, okay, let's partner with Google, because they are also kind of pioneers, and I mean, like to like, they are quite like-minded. So you won't be surprised, 2016 is when they started off their cloud migration. By 2017, they were completely on Google Cloud Platform, working out in cloud. And by 2018, the next year, so they had their last data center, which they retired. So imagine the journey, started off in 2016, 2017, they were fully on cloud, and 2018, they just retired the data center. See the kind of, stuff they would have taken with a built on their own data centers to cloud. So that is their quick journey. Apart from that, they also leveraged, many different, I would say, services. The BigQuery was one of them. So BigQuery is just like a service wherein, you can query, and this query actually runs on a petabyte scale of a data. This is for mostly for your warehousing and analytics, which they have used. Apart from them, all the soundtracks, all the music and all, they have to be stored somewhere on the storage platform. So how would you ingest that? How would you actually upload all those songs there? How quickly can they be downloaded? What kind of network benefit would it provide? What kind of bandwidth would it provide? Apart from that, they use the latest and the greatest AI platform, which was provided by Google, for again the recommendation system. Just like Netflix, it gives you recommendations. Similarly, Spotify also gives you those kind of recommendations. So again, what were the success factors? As I said, they were struggling with the streaming services, so their scalability has been improved. So that is one thing which always happens in cloud. When we move to cloud, you can quickly scale. That is the beauty of cloud. You can quickly scale within a few seconds. That is the how quickly you can do it. Apart from that, they if you see, they reduce their infrastructure cost. So what I found out was they reported it to be down by 30%. So whatever they were spending on their infrastructure cost, they actually were able to save that much. So again, so they use some kind of machine learning capabilities by again training their machine learning models to find out what are the likes of the customers of, or what can kind of personalized recommendation they can provide. Apart from that, okay, any cloud provider will have a global availability. That is how their content can be distributed with a very low latency. So the latency here means, from the server, which is on the Google, to your devices, how much time it takes to reach the content to your device. So the low latency, if it is in, let's say, microseconds, it is beneficial. Even milliseconds should be fine, but if in having in microsecond, your ears won't be able to decipher if it is really low. If it is, there is a lag in between. Let's go to the next one, which is a case study of a Coca-Cola. Now, you were able to relate to what a Netflix is, you were able to relate to what a Spotify is. I'm pretty sure, when it comes to Coke or Coca-Cola, you will not be able to relate to, what could be there for them to, because they don't stream. They're just in a company that's selling beverages. So what Coca-Cola as a company had is, if you know the business model of Coke or Coca-Cola, and or any, I would say, Pepsi or Coca-Cola or any beverage provider. So what they usually do is they have actually targeted, or they partner with bottling companies. So bottling companies are the one actually who are going to, set up, they're located across the globe, and they are the ones actually who actually produce, or I would say make, the drink for people, and they sell out in the market. The problem with Coca-Cola was, when you have partnered with so many bottling companies, how would you actually collate all the data together? How would you know that, what is the demand? So it was the onus of all those bottling companies to figure out what the demand is, to figure out and place orders. Sometimes they were overstocked, sometimes they was understocked. This is how it was. Eventually, it was, if it was a problem with any bottling company, so that reflects directly on Coke. That reflecting on the Coca-Cola reputation. That this drink is not available. And apart from that, every different bottling company, they were storing the data in different format. Let's say somebody stored in Excel sheet, somebody stored in a text format, somebody might have used, some kind of a database. So they were data which was there in many different systems. And that is where Coca-Cola thought that why not, we push this data to cloud. Why not we push this, data to cloud, wherein we have data in a centralized location. So that is one thing which they wanted to improve. Apart from that, again, if you have a data which is in centralized location, you could predict what could be the demand. They can easily, then that way you can cater to the quick demand and supply capabilities. And that is one thing. Apart from that, they also started innovating their platform. So how they innovated the platform is, there's one thing which actually, which happened, during the COVID time. We were not able to touch, or place orders. We were kind of secluded at our homes. Now Coca-Cola came up with a machine called Coca-Cola Freestyle, wherein you can just, operate that machine with your phone. You just have to log in and choose a drink, and that is how they were able to do it using AWS. So this is one of a classical case study, during COVID times, how they quickly were able to expand their business using that kind of a machines. So eventually, they bottled down. They thought of using AWS and Azure. That is why what we call as a multi-cloud strategy. Again, when we talk about, you might think, why AWS, why Azure? So people tend to pick up cloud service providers based on their capabilities, based on the pricing advantage. So for example, if me as a company, I'm using more of my Microsoft products, definitely it makes more sense to have Azure, because I might get a pricing advantage as compared to AWS. But it all depends upon how I use cloud. So they thought of using AWS and Azure, and most of their artificial intelligence and machine learning capabilities for their marketing campaigns, for their other things, which they actually wanted to collate the data. They actually used Azure for that, and all the serverless, especially the Coca-Cola Freestyle, which I refer to, so that people can actually use their mobile phones to just go and order a drink for them. Actually, they started using, with their serverless and the AWS functions. That is more towards the data and IoT solutions, Internet of Things solution. So eventually, the success factor, as I said, they were able to rapidly, deploy all this around the globe, because they were able to choose a cloud provider which has presence throughout, and they were able to push all these things. Now the data which was scattered around, so they had the data within them at one single place. They were able to make better decisions, specifically, predict the forecast and deliver all the things. And also they achieved like mighty cost advantage, because the kind of data which they had, they have to parse the data, store that in the old fashioned way. Now everything was done, on a common platform. And eventually, as I said, the sales, personalized experience globally with the Coca-Cola Freestyle. This is one of those things which I always take up in my case study as in my lectures, in my 90 minutes lecture, especially with the Coca-Cola freestyle. What exactly happened? What was the pain areas? How in the during the COVID days they were able to scale up super quick. So that is one of the examples. Let's move to the next one now. Let's take example of Formula One. So the Formula One is also a classic example. The we are going to talk about data here. So when we talk about any racing car, so the racing cars actually generate a lot of data. So in each and every car would have around 100 or more than 100 sensors, and each sensors are going to measure specific thing. For example, we talk about RPMs, we talk about let's say the brake pressure, we talk about the temperature which is there for generated, the tire pressure and whatnot. Like there are multiple different parameters which are getting measured for each and every single car. Or each car, let's say if it runs a single lap, you might be surprised, so the the scale of data is actually is MBs, around 100 MB in single lap. Imagine your data being collected for this one car. How about 20 cars which are there in the race? So much of huge amount of data is getting collected in real time using sensors. So the problem, with Formula One racing as such was how if they are setting up their own servers, the problem was, when the data is being generated at such a huge scale, they were not able to catch up. They were not able to ingest the data in their systems. And sometimes, you have to, let's say, data gets dropped, it get lost from the sensor because they were not quick enough to just, ingest the data. So that is one of the problem which they faced. Apart from that, they wanted a system wherein, when you have so much of data streaming. So nowadays when you look at the Formula One racing, you will see some kind of graphics shown. They might kind of predict, if this is a racer which is going at such and such speed, and if they kind of finish this lap with whatever they are doing right now with the same speed and same everything, so they have a chances to win the race. How was that done? So the thing is, like, they have historic amount of data which expands around petabyte of scale. They were able to churn those numbers real quick. They were able to, because this is all telemetry, really complex data. But how would you be able to understand this data? So you need to have a systems in place which can do this kind of algorithms for you and display in real time. So I mean, the broadcasters would be able to show you something which is really meaningful, all the data, telemetry data which was collected. So this was the real use case for them for Formula One. Apart from that, you think about another thing. The races are going to happen across the geography, right? So how are they going to actually, are they going to take up their entire computing power along with them? So that was another problem. Even if I think of having servers which can do all these things for us, so can they ship them all the servers, all the IT along with them? No, that was a problem. So that is where they thought, let's why not hook up to a cloud provider. Wherever the race is going to happen, we need a platform where we can ingest the data quickly. We can have the latest features wherein we can kind of train the algorithms. We can predict what who is, let's say, will be the winner, or whatever what parameters are required for somebody to win the race. Something like this. That is what they thought. Then they started off their cloud journey to AWS, and for this AWS they use multiple things. First of all, they started using Kinesis. If you think about Kinesis, they solved one problem, which is your data stream, how you can quickly push all the data which was generated. So this is a real quick data ingestion system. Apart from that, how you can quickly have the capabilities of this data, how you can quickly query, generate insights, quick insights using Amazon quick sites into the visualization. That's what the broadcasters are actually using nowadays. And then they use SageMaker. So SageMaker, they give you some kind of pre-built AI and machine learning models. So they had all the data with them. They pushed that data into it, and then they were able to, with that data, they were able to find out, who's going to be the winner. And specifically, year 2022, there were some changes in the rules, and that time, the card design also changed. So that time they also wanted to have a capability wherein they can, simulate, what changes they need to make uh, in the car and run those kind of simulations. And in the data centers, it took around 60 hours to run. For example, one change they made into the car and simulated, it took 60 hours to get an outcome. So once they moved to cloud, so that they were able to, parallelly do all this high computational sensitive simulations. And that time from 60 hours were dropped to 12 hours. So they were quickly able to test, what changes they can do, how they can prototype it, And that was a big reflection on, how they were able to achieve with those different rules in 2022, how they were able to change the design of the cars. So that is what they actually achieved. If you see the success factors, so what are the real time data processing, how they were able to process the data in real time, so with no data loss, and then the kind of services which they use were far enhanced. Again, the broadcaster was able to present you with F1 insights. And again, that, so as I said, rapid prototyping, they helped them innovating the car design. So they were able to also handle enormous amount of volumes of data, because as I said, each car has like around 100 or more than 100 sensors. How would you connect all the sensors back in and feed the data in real time? So those were some of the success factors. So let's move to the next one, a popular case study about Volkswagen. And again, like this, if you think about Volkswagen, I will typically quote one thing. So Volkswagen, they have a fleet of cars under their radar. You can think of Audi, Porsche, Skoda, whatnot. Like they have a fleet of cars. So their cloud journey started off with the concept of, so they wanted to have a Volkswagen automotive cloud, but I will put it in a different way. They wanted to have something called a software defined vehicle. They wanted to have something, intelligent car, wherein, for example, if they want to push a change in a car, they could be able to do it with a small software change. Imagine, that was their brilliance. They thought about, how about, if you're driving the car, your car is context aware. It is so smart that, if you're passing by, let's say, a gas station, it is going to check your car and see that, you need to refuel. And the gas station, let's say, which is 2 kilometers away from you, is going to give you the gas at a very competitive price, or a price which is lower than the other providers. So that is a kind of a smart car which they thought about, a software defined car. Also, for example, the car is also aware of the kind of movies you like. For example, if you're just driving the car, and they will quickly tell you, okay, this is a cinema nearby, and this is a new movie which has been launched, and I think you would like it. Would you want me to book a ticket for you? So this is just a kind of a context which I'm setting up here. So this is their vision, that they wanted to have some very smart car. Apart from that, just like Tesla, they push the software updates, what we call it over the air updates. They also wanted to have a mechanism wherein they can push software updates on the air. You don't have to take your car to the dealership to get all these done. So, but eventually, what happened was, when they actually started doing it, it was super flop. The reason was, there were major amount of bugs in their system which they have actually built. Now they wanted to leverage, cloud to actually solve all the problems which they had. So that is where, the Volkswagen automotive cloud came into being, where they thought, okay, why not if we, let's say, release a software, let's try to release it to, let's say, 5% of the cars. How can we connect the cards? How can we measure telemetry and all those things? How we can measure the performance and see this quick change which you have introduced is not causing any trouble? And then they started releasing this to the other 95% of the people. So they just want to have this kind of feature and facility in place, and they could only be able to do this with, the cloud. So they actually tied up with Microsoft Azure. And again, so they were able to use many of the services which relate to IoT and machine learning to actually implement what they have envisioned as a software defined car. So that is what they were able to do. So then again, as a success factor, again uh, they were able to scale, and they were able to get the data which they always wanted to do for the connected cars. And again, their cars were able to get the context of the people. For example, if I'm not driving the car, I will have a different context. So context here means my likes, my dislikes, what kind of my car is, what kind of gas station I like. So usually people have preferred choices. They will go to one gas station than the other one, right? Those kind of devices, if they are context aware, they could be able to recommend you that way. But the context is actually recommendation system is actually established when you look at more customers. You look at diverse set of background of the customers, and what are driving the people who are driving the car. So that is one thing which they were able to do. Apart from then, when they moved to cloud, they were thinking about the autonomous cars as well. How they can driverless cars, how they can create their cars which are driverless. So they need algorithms which they could run, the machine learning and the AI algorithms, which could actually help them build those kind of solutions. So this is what their business was, and how actually they transformed their business using the cloud. Then we have Starbucks. So again, the Starbucks case study was actually pretty simple. They were struggling with, they were struggling with mobile ordering and the payment experience. So there were frustrations. So they started off with the app, and the app was not able to scale. Sometimes the customer, has provided the order from a particular location, the let's say the drink was not available or the snack was not available, but the app used to show that it is available. So this kind of problems they used to face. And then apart from that, they were not able to make recommendations. So this is recommendation is now becoming popular, more and more popular. All the different apps and all, they will give you personalized recommendation, but this recommendation can be in terms of your loyalty program or in terms of discounts. For example, if somebody always had a coffee and a specific choice of cake, now they will get to know, okay, if I give a discount, the chances are the person is going to go and get that particular kind of experience. So eventually their problem was with mobile ordering and payment experience. So they actually had their own data center, but again the problem was that they were not able to expand their capabilities when it come to the mobile experience. And now what they thought was they never wanted to let go of their cloud or let go of their on-premise system. That is a typical case study of a hybrid approach. So they had their own data center, but they wanted to enhance their capabilities. So again, they partnered with Microsoft Azure. So right now, currently, whenever you go to Starbucks, if you order something, so the chances are the order and the payment and all those things are actually processed using Azure. But eventually, most of the other things which they were doing before, for example, inventory management and all those things, are still taken care of by their existing data center. So eventually, Azure was able to help them with mobile ordering, their data analytics platform, some recommendation. So even if, as I said, the background or the inventory part was taken care of by their own data center, but the forecasting of the demand and all those things were taken care of by their cloud data center. Even their loyalty programs and all those things were actually improved using Azure. So again, the success factor are still the same. They were able to scale. The main problem which they had was, mobile ordering, their payments. All this now were able to being processed by Microsoft Azure, and their loyalty program also was spot on with that. Let's move on to the last case study. I hope I'm not I'm not being boring you presenting this case study. I'm boring you, but yeah, this is the last one. I'll again open the floor for the question which you have. Now, the next use case is for NASA, which is specifically Jet Propulsion Laboratory, which is commonly known as JPL. So, I'm not sure how many of you would know, but JPL is one of those organizations within NASA, which is, I would say that, they are the forefront of all the latest and the greatest programs. You talk about Mars rover program, you talk about, the Earth Observatory Satellite Program. So they are the kind of a forefront for all these kind of programs. Now, now the problem is, do we really think NASA is not capable of having their own data centers? Yes, they are definitely they're much more capable, but the problem with NASA was scaling. So that was the main problem. So they had their systems in place, but the way they are kind of expanding their systems, how would you actually process this amount of data? So if you see, in this image I've shown, there are multiple, uh, you know, the data is coming to the data centers from, let's say this kind of satellites or, some kind of imaging system and whatnot. So there are multiple things which are coming to the NASA data centers, and HPC is nothing but, your high performance computing. So they are the ones who perform the simulations and provide you with the results. And then based on the results, sometimes you have to take a decision, and let's say, you have to course correct some of the satellites or the imagery systems and all those things. Now the problem was, as I said, they were not able to expand, they were not able to scale. So that is where they thought, that they need the capabilities of the cloud, so that they can just process these data at a very good scale. Eventually what they wanted of was they wanted a storage and computing capability. Right now what they used to do is, so for example, an image or let's say the sensors are sending a data, and that data was in, let's say, petabyte scale. So those are going to go in their data center, and now if they want to analyze that data of a petabyte scale are going to be loaded into the machine where they're running the algorithms. Now that is what they actually achieved by having a multi-cloud strategy. So they actually targeted all the three major cloud providers, the Google, Amazon, and AWS. And what they eventually done was that they set up their virtual machines. They wanted a compute, storage, and other capability, and they wanted to control. They wanted to run their own algorithms. Also, they wanted to have cloud providers to store the high and massive amount of data, which spans the petabyte scale on their own data centers. And now, if they want to run their algorithms, they don't have to download that image to their local systems. They can do that on your virtual machines with their provision on those particular cloud providers. Now, somebody might ask, why they have done with three cloud providers. Just because, all the three cloud providers will give you different kind of cloud capabilities or capacity as in terms of virtual machine. Because the processing, for example, to give you a very simple example, it might not be too relatable, but let's say, the Google Cloud has, you know, Intel capabilities, AWS has got, some other capabilities, high performance scale. Azure is going to give you, FPGA. So these kind of capabilities. So different capabilities are provided by different kind of cloud providers. So they actually has gone ahead with all the three cloud providers. Then again, as I said, so they were able to rapidly provision and deprovision. Provision and deprovision here means they were able to rapidly create new virtual machines. They were to quickly analyze the data, and once they have analyzed, they will shut down the virtual machines. And that is how, so they were able to do this real quick. They were able to scale real fast, and they were able to scale up. They were able to scale down really fast. Then apart from that, they were able to make scientific discoveries. As I said, so if now there is always a delay when the data comes from the telemetry, which is there in the space, to the earth station, then you process it, take a decision, send it back. Now, if we can somehow control, because we have no control on the way how that latency is being built from the space to the earth, but if we can do something when the data comes to earth, if we can process it real faster and take some decision to course correct, then we can actually do a lot better. That is why they were able to make a lot of scientific discoveries. And eventually, they were able to share the data, collaborate among different researchers, because the data which is on one cloud platform, the cloud is actually a global resource. You can able to replicate the data. So even if a data scientist sitting in Europe or maybe sitting somewhere in North America, they could be able to use the data sets. There'll be two copies of a data because of the global scale. They'll be able to use it real quick. And then again, they got cost efficiencies as they were able to rapidly provision and deprovision all the systems. So this is what it was from your case study perspective. I'm pretty sure you would have got to know the idea of how this cloud computing, I mean, how these companies actually use cloud computing to their use and what were the various needs. So I tried to capture different variations of, so that you can understand it's not only a single use case, it's a multiple kind of use cases which they actually use. So now coming back to the careers in cloud computing, the variety of careers which are there in cloud computing started off with cloud engineer. The cloud engineers can be, one who actually devise solution for the customers. They actually work with a lot of customers, and they, look at how to devise a solution for them. Then your developer and operation engineer, DevOps engineer. So that is where, your operation capability and your development capability, they marry each other. And that is again one of those skills which are very popular nowadays, right in demand. Then your AI and machine learning engineer. So even if you have a bit of a background in AI and ML, how are you going to, let's say, the models which are being offered by cloud providers, how would you train them? How would you tweak them, configure them? How you can actually use them for your AI and ML use cases. Then the cloud security analyst, one of those areas wherein, so people think that cloud is, not secure. Some of them think the cloud is more secure. Eventually, it boils down to the way how actually you manage the cloud. We need to understand, what are the capabilities, what are those things which the cloud provider is going to manage, what are we going to manage. So the cloud security analysts are one of them, which are going to help you get these things done. Then the site reliability engineer. The site reliability engineering, actually, the concept was coined by Google. So there are a lot of jobs in place in the market if you search for your site reliability engineering. So they actually are all about, different cloud engineer jobs or DevOps engineer jobs. But eventually they target more towards site reliability. They're kind of a bridge between your, I would say, your CEO or the, the customers and the engineering team. So they are kind of a bridge between this. That is a site liability engineer. Then again, you have multiple cloud trainers and evangelists, because cloud is big. More people are going to cloud, migrating the cloud. How they can do that? How people can, use cloud? There are a lot of certifications from each and other cloud providers, and also, these trainers actually help you. Train you so that you can work in cloud. Apart from that, they also work with, just like cloud engineers, formulating different solutions for the customers which they need. Then how can you get started? They're very easy step. First of all, each and every cloud provider gives you a free cloud account. So you can open your account in there. You can attend free courses. Each and every cloud provider, different platform, they can give you free courses. Start bit by bit, and then start getting hand-on experience. Create some mini projects, and then also join communities. The communities are going to help you, answer most of your technical questions, and then build your own cloud portfolio which you can actually showcase when you go for an interview. You can tell them, this is what you have, what are the projects you have built, and even showcase some of the certifications which you have. At OPIT, what we do is for your cloud computing courses, we actually have all the courses which are actually aligned to your certification program. So eventually, by the end of the program, you can go ahead and study and then get yourself certified. So it actually makes a lot of value. And all the courses which we have at OPIT actually are really practical, filled with all the use cases. And by the end of those courses, you can start thinking in terms of the architecture capability. How would you devise a solution? So that is what we do at OPIT and how our courses actually program. So that's it from me. Thank you so much for your time. And if you have any questions, do let me know. I'll be able to answer those.
Thank you so much. That was very insightful. And like there was a question before about the careers, but you answered that now. So that was, thank you so much for saying that. There was a question before as well. Maybe you can just answer that. Like, how do you keep updated with the different platforms and the different scenarios? Like, is the cloud changing very quickly? Is it something that you need to continuously study?
That is correct. So the basics are almost the same. What actually changes is, sometimes they will change the UI, sometimes they will come up with the new capabilities. That is why, each and every cloud provider, if you're certified, if you have certification, you need to renew your certification every three
Okay.
years. So that is how you have to keep the pace up.
Okay, so that means that you have just continuously adjourn yourself. And can you,
Yeah.
there was another question before about the cloud. Can you use the different provide, like what if you become a specialist in AWS? You need to do AWS and then Azure and then move from one platform to
Uh,
another.
Yes, I mean that's a classical thing, and even I'm the kind of the person who has started off with AWS, then I have set up my footprint in all GCP and Azure as well. So it doesn't make a lot of difference. The thing is, we all are think about this, that we are engineers. We are not very specific that we just do the things how we are taught, but we have kind of mindset wherein we can take the things from one platform and implement to other ones, because the concept remains the same.
Are the
If I talk
same.
about computing, the virtual machine, the naming might be different. The virtual machine will be the same. The source storage will be the same. The only thing is how it appears on your UI, that will be a little different. The architecture wise, that is what, like in our courses, cloud computing courses, though we usually stick with one cloud provider, but what we usually do is, like, I always go and give you examples. For example, if I share one architecture diagram, we tend to give you another architecture diagram which will be suitable, which you understand. Okay, somebody might have experience, let's say, with GCP. How would they design architect something in Azure? So that is what we actually use in our cloud courses as well. We understand that, so this is the demand. So just for example, the NASA case study, they had all the three cloud providers, right? So that is what you need to understand in this age, that you should be able to work with all of them.
All of them. Okay. Okay. Thank you so much. I don't know if there are other questions for Professor Lokesh. You can also write them to me and then I would just deliver them. I think there is a question. Will soon be expected to have an integer platform that work with all clouds transparently? That's from Wow.
Yes, there
Mm.
is a very, very good question.
Mhm.
Uh, so actually, this is something which I actually take up in my live sessions as well. That, so if you are with one cloud provider, do you really think that you are stuck in there? How would you move to another cloud provider? And is there anything which you can do, whether you can move your one workload to another cloud provider? That is where, the cloud native app, so microservices architecture, the containerization helps you in place. That you build your application in a container, and if you want to port your application from AWS to GCP to Azure, you are free to do it. Even if you can run those container applications on your laptop. I mean, that is what you have to think about it, right? I hope I've kind of answered your question. I'm just looking at the question on my side screen. Yeah.
Yes. Okay. Thank you so much. Is there any other question from the audience, or do you feel like otherwise? I think you cover very well the cases. I was surprised by some of them. I have to be honest. Like I wasn't expecting Coca-Cola, but yes, that was very clear what you explained why and the logistics behind. Okay, so if you have other questions, you want to reach out to me. Oh, I think there is another one. No, just many thanks.
Thank you.
Okay, thanks to you. So you can get back to me, and I will just liaise with Professor Lokesh. She's also available on LinkedIn in case you need to reach out to him.